All right, welcome back to another math video. Last video, we took a look at doing some trig in standard position if we know a point on the arm, okay, if know a point on the arm, but it's not actually new. It's math 10 trigonometry. All we did is some relabeling. Opposite is y, adjacent is x, and hypotenuse is r, okay, and we can calculate r or any of the missing side really with Pythagorean theorem. That sounds just like Math 10 trig. Okay, Math 10 trig. The only thing changed, okay, that's actually different besides the relabeling is the sign of your trig ratios, and that's what we're going to start by investigating it. I did left a conundrum on our last video. Hopefully you actually looked it over and think about it, okay, because that does come into today's lesson, and we're going to resolve it in some form, okay? So before we begin, let's do a quick review. Okay, of course, hypotenuse is r equal to x squared plus y squared. So r is always positive. So r is equal to the positive square root of x squared plus y squared if you want. Okay, that's just our convention. And with that, what we can do is sine of the angle is, I'm going to skip the angle. Y over r cos, I'm just going to skip the angle. X over r tan. When you write the work, you should write the whole thing, but here I'm just writing a quick recap. So tangent is y over x. Now, because y, x, and r are not just length, they're not always positive. They're sometimes positive, sometimes negative, except r is always positive. Okay, so r is always positive. Okay, but that's not true for x and y. So consider each fourth quadrant. In each quadrant, how does the sign of x and y change? Okay, sign, not trig ratio, the positive or negative of it. All right. So in the first quadrant, of course, in quadrant 1, x is positive, y is positive. Of course, r is always positive. So if we do that, sign is y over r, so it's positive over positive. So sine is positive. Cosine is the same thing. Tangent is also the same thing. So conclusion, sine, cosine, and tangent are all positive. Hopefully this is no surprise to anyone who have worked with math 10 trigonometry, okay? Because all the angles we work with are acute and they're always positive. That is not true in quadrant 2. Quadrant 2, x is now negative, but y is still positive, right? So x is now negative, y is positive. Okay, r always positive, of course. So sine is y over r. Sine is y over r, both positive. Sine remains positive. Wink, wink. Ambiguous case for sine law. Wink, wink. Okay, not quite there yet, but it's related to it. Cosine, of course, okay, is x over r, but x is now negative over positive. So cosine is negative. And tangent, of course, is y over x. Oops, made a mistake. Oh, no, I didn't. Y is positive. Positive over negative. So y tangent is also negative. Okay, so only sine is positive. Here, all of them are positive. Okay, I'll let you fill out the rest, okay, on your own. Determine what x, y, r are, the sign, on your own. And complete this chart. But I'm just going to review the answer here. But please actually go check, complete the chart. But I can tell you here, sine is negative, y is negative, tangent is positive. Quadrant 4, sine is negative, cosine is positive, tangent is negative. Just speeding it up a little bit. Okay? So to put a summary, okay, I'm going to use S for sine, C for tan, and C for cosine, and T for tangent. Then what ratios are positive in quadrant 1? Well, all of them. None are negative. Quadrant 2, only sine is positive. Cosine and tangent are negative. Only tan is positive. Okay, you can even say this as all. Right? sine and cosine are both negative, and in quadrant 4, only cosine is positive, tangent and sine is negative. So what can we conclude from this observation besides the sine? Well, one other key confirmation, hopefully you notice, is other than quadrant 1, except, which is special, everything is positive. Now cannot spell. Except Q1, where all is positive. Only one trig ratio can be positive. Okay, so I might trick you. Hey, so I tell you the sine of an angle is positive, cosine of an angle is positive, but tan is negative. That's impossible. Okay, they are all positive, or only one is positive. All positive, or one positive. You cannot. It's impossible to have only two positive. Okay, all positive, or one positive. Okay, all right. And of course, our second conclusion is that it's related to the coordinates of the point, right? It's determined by the coordinate of the point. By coordinate, just write chord points on the terminal arm. I guess it's no surprise, consider our last lesson, right? So is there a neat way to record it? Well, there is. Just draw the coordinate plane. All right. The quadrant 1, all is positive, so all positive. All right. Quadrant 2, only sine is positive, so sine is positive. Quadrant 3, only tangent is positive, so tan is positive. And last one is cos is positive, so only cosine is positive. Or if we simplify that, we just remember A, S, T, C. But that's not too easy to remember. So actually remember from the C here, this is called the cast rule. See? C-A-S-T. This is called the cast rule. But where do we cast start? You want to be careful. You don't want to start C here by mistake. Okay, so I actually always start with the A because all is always positive here. So A is, so remember two things, cast and Q quadrant 1 is A. Okay, quadrant 1 is all positive. Okay, let me fill it in. So what do we do is like, okay, I need to solve a trig problem. I want to know sine. Oh, okay, oh, I remember all is positive here. Then I follow cast in the positive direction. A is the second letter, so C must be here. C-A-S-T. Okay, like that. Okay, so that's how to, it's a quick way to remember it, but even if you forget, use the coordinate point and drive it again. It may take a little longer. This does make it a lot faster. Okay, so this is the cast rule. We can tell a trig ratio is positive or negative before we even solve them, just by recognizing which quadrant the terminal arm is in. Let's solve a quick problem. Okay, let's solve a quick problem. And then we're going to answer that conundrum question coming up. So, tangent of A is less than 0. Determine which quadrant the terminal arm of the angle is in each situation. Okay, so tangent is negative. Tangent is negative. Let's see. So tan is negative. Let's write down cast rule A. Start with A. C-A-S-T. T is positive, all positive. So I'm going to write positive in here. Oh, doesn't allow me to only erase the circle. So be it. So it's positive here and positive here. And it's negative here and it's negative here. Oh, wait. Negative and negative in quadrant 2 and 4. So this one is quadrant 2 and quadrant 4. Just like that. Okay. Now we do the same thing. Sine of the angle is greater than 0, right? Draw the cast rule again. Positive here, positive here. Tangent is not sine, cosine is tan. Oh, sine is positive here. So quadrant 1 and 2. All right. The last one is a little interesting. I would like you to check it for yourself. Okay, the answer is in the notes, so check yourself. Okay, so check the answer for yourself. So now we're going to answer the conundrum. We're going to tie this into our problem here. Okay, so first we're dealing with the angles, again with the point. All right, so let's draw the angle. 0, 5, that's very easy. X equal to 0, y equals to 5. Oh, sorry. I got ahead of myself. I forgot to actually answer the conundrum question. So now we're going to use this combined with our what we learned to solve our conundrum. Okay. Remember before, our conundrum is, I drew the angle here. I forgot the angle itself, but doesn't really matter. I think the point was -3 and -4. Comment on my video. Say, yep, we got it right. If I did, it was indeed -3, -4 from my last video. And I think I drew a red reference angle right here and formed a right angle triangle. Right? We know that the sine of the angle itself, right? This is the angle. Sine of the angle is -4 over whatever, 5. So the length is 5. Cos is -3 over 5. And sine tan is -4 positive 4 over 3 because negative cancels. So 4 over 3. Then the question I asked last time was, what about the trig ratio for the reference angles, right? Well, let's do that. Let's use the right angle triangle to find it. So the red right angle triangle is right here. The opposite is -4. The adjacent is x, once again, -3. And hypotenuse is 5. So sine of the reference angle, now that I labeled it, you probably see it already, opposite over hypotenuse, -4 over 5. Okay, I'm not going to do a circle again. No, that's the same. Maybe that's coincidence. You know it's not. Cos of theta r is -3. That's adjacent over 5. Whoa, what a surprise. Tangent of the angle is 4 opposite over adjacent 3, or -4 over 3. That's just 4 over 3. Oh, same again. Right? Same again. Is that a coincidence? For those who are perceptive, you might notice it's not a coincidence because the opposite of theta r is the y value. Opposite of r is y. Okay, it's not just a coincidence it's not just a coincidence we let O be y, x be a, and r always positive. It's because if we use a right angle triangle, for the reference angle, we actually get this matchup, right? Actually get this matchup. Okay, hypotenuse of the reference angle is r. So we're not defining it out of nowhere. So with that conclusion, this is a big conclusion we want to reach, that the trig of an angle is equal to the trig of its reference angle, except if we ignore, but the reference angle can only be positive, right? Trig can really be positive. So we do want to be careful. Technically, it can be positive or negative. Not positive. and negative. Okay, not positive and negative. I'm just saying the trig ratio is either that or that. Okay, that or that. Okay, we'll see. We'll do one in a quick. We'll do a really quick example. Okay, that or that. Okay, sine or same thing for cos, same thing for tan. Okay, it cannot be both, but not both. Okay, it cannot be positive and negative at the same time. Okay, not both. So it's sine theta r or negative sine theta r. So you might ask, how do we know which one is it? How do we know it's positive or negative? Is there something we have learned recently that tells me which when the trig ratio is positive or negative? I wonder, is there anything that helps me determine the sign, not trig, the direction, I guess, of the trig ratios? I wonder. Casserole. Well, let's do a really quick example to keep it very simple. So let's see, what is cosine of 215 degrees? Let's round it to 3 sig digs. 3 sig dig. Okay, I'll keep this short because there'll be plenty of practice coming up. Well, first let's sketch the angle. 215 is just a little bit longer, bigger than 180. The reference angle is our favorite friend, 35 degrees. That's my theta r. And the whole angle is 215 degrees. Then what we can say is, well, first let's determine the sine. All is here. Just first, casserole. It's in quadrant 3. So arms in quadrant 3, which means cosine, only tangent is positive. Since only tangent is positive, cosine must be negative. Tan is positive, so cos is negative. Okay, so immediately we know cosine of 215 is equal to a negative number. Okay, negative number. Then step 2, we're going to use our reference angle to find the value. Step 2 is the reference angle is equal to, in this case, I'm going to actually calculate, even though we remember what it is. The reason we calculate like such is because it's in Q3 again. So reference angle is 35 degrees. Since it's our reference angle and we know the trig ratio of the reference angle is the same as the actual angle up to a sine, so we can just go cos 215 is, I'm going to put a quotation marks, equals cos 35. But let's not write it here. That's not too helpful. Let's go straight to our actual expression, which means we know it's negative, and the value is cos of 35 degrees. Okay, remember this is our theta r. Then we just need to type into our calculator. Type it into our calculator. Okay, and boom, boom. Once you type into your calculator, okay, I'm going to do that quickly. If you share the calculator background, that's what I'm doing. Okay, make sure your calculator is in degree mode. So cosine of 35 is 0.819 something. So it's negative approximately 819. So that's the cosine of 215 degrees. All right. And so that is how we calculate the trig ratio of a specific angle. Of course, you can do sine. Sine is also negative, right? Sine is also negative, so negative sine of 35 degrees. Tangent is, be careful, tangent is positive in coordinate 3. So it's equal to positive 10 of 35. I'll leave you to calculate it with your calculator here. 35, not 6. Okay, 35 here. I'll leave that, but I think it's a good time to wrap up the video. Okay, the question I skipped actually ties into our next lesson. It's how to remember the trig ratios of some specific angles. Okay, I'll go back to the question, but this is how you find the trig ratio of any angle in general. Okay, first, determine the sine. Second, use the reference angle to find the value. So step 1, sine with cast. Step 2, value using the reference angle. All right, that's it. All right, let's go back to the question I skipped. There are 2 questions here, 3 and 4. Okay, skipping ahead. That ties into our next lesson, exact values of angles. We're looking at 2 very special angles here. Okay, one point is 0.5 on the y-axis. Okay, other one is -8.0 on the x-axis. Okay, think about the trig ratio of these 2 angles and see what their values are. See what their values are. What do you think the reference angle is, and all that, and tie in with our information we've done in this class, this lesson. Okay, and then we'll use this jumping off to remember some special trig ratios for some special angles. And with that, thank you for watching. We'll see you next lesson. I'll bring back the question that wraps all questions. Okay, this question is the most common type of question in this unit. If you understand how to do this backwards and forward, then terminal arms, the angle standard position should be fairly easy. Okay, fairly easy. Okay, sorry, I rambled on. Thank you for watching. I'll see you in the next video.